All right, sweet. Recording has started. And so this is the Crossplane project office hours for Kubecon EU 2020. So I don't think we've done this before, especially not virtually. Crossplane is a pretty brand new CNCF project. We just got accepted into the sandbox like a month and a half or 2 months ago, maybe. So it's pretty recent. That we're now part of the sandbox. So this is our first KubeCon event being part of the CNCF, so that's exciting. Yeah, so let's, by the way, this could be a very interactive session, so I'm gonna go through some slides and do a demo and such, but anyone is more than welcome to pop a question up. You can use chat or you can just interrupt anytime you want, so we can keep it very dialogue-y if we want to there. So let's talk about what Crossplane is. So it started with the first release, taking the repo public. The V0.1 release was back in December of 2018. So it's like a year and a half ago or so. And this is actually a project, we'll get into more details about the history, but it's a project that was created by the same folks, myself included, that created the Rook project. Rook is, a CNCF project that's hopefully going to be graduating soon. It's been in the graduation vote for a little bit here, but yeah. So we, saw a need for what Crossplane is trying to solve as well while we were working on the Rook project, and so that's how we kind of got it started there. It's based on the Kubernetes control plane. Let's be very clear about the architecture. That it's not a completely new thing written from scratch. It is based. You can think of it as a Kubernetes add-on. Actually, it's a set of controllers that are reconciling CRDs. So it uses the Kubernetes control plane principles and architecture. So it's very Kubernetes native and running inside Kubernetes pretty much as an add-on, you can think. There's three main feature areas for Crossplane. One of them is about provisioning infrastructure. So being able to use Crossplane directly from kubectl to say kubectl creates and then some sort of cloud infrastructure like a managed service like a database or a security group or whatever it may be across a wide set of cloud providers. So creating infrastructure from inside of Kubernetes is a big core of the project. And then so you can start building on top of that though by creating your own platform or your own API around provisioning infrastructure and then making that available to your applications when they need. And we'll get into more details on all of these, obviously. But then the third main feature area is about running applications up to the application layer and being able to not only provision the infrastructure that they need, but then also run the applications as well. We talked about a little bit about the history about, as working on the Rook project, we saw a need for this project as well, but a little more detail on that is that we found the volume abstraction in Kubernetes to be super powerful, where an application can express that it needs a volume and it can get that on demand and not have to know any of the details about it. It could be like a Google persistent disk or an Amazon EBS volume or like Rook Ceph volume, whatever it may be. The application just simply has to express that it needs the volume, and the machinery will provide that on demand, without having to know all the details of it. So we saw that in Rook, and we were thinking, gosh, that's really powerful abstraction. That enables portability and flexibility, separation of concerns, all sorts of cool stuff like that. So we thought it'd be useful to apply that to a whole lot of other types of infrastructure like caches and databases and even Kubernetes clusters themselves. So we got started on that. That was the original vision of Crossplane. And then more recently, we've joined up with Microsoft and Alibaba as well to work on the open application model spec, the OM spec, and then have Crossplane be the implementation of that for Kubernetes. So infrastructure, provisioning infrastructure, running applications, all that sort of stuff. So let's dive in a little bit more into the first main feature area of Crossplane. So that's all about using the Kubernetes API to provision infrastructure. So the way that we do this here, and there's a little diagram on the bottom there, is that we represent infrastructure in cloud provider managed services, et cetera, as CRDs inside of Kubernetes, as Kubernetes objects. So, either application or a operator or whoever it may be can use the Kubernetes API to create an instance of a CRD. Let's say one for Amazon's relational database service, Amazon RDS. And then so that CRD gets created in the Kubernetes API server, and then Crossplane has a set of controllers that are watching for these CRDs with the Kubernetes API server. And then that RDS controller would say, oh, so some user has requested a RDS database. It's going to look at the spec, and then it's going to talk to Amazon, the AWS, over via the Amazon's API to actually create that. So the desired state that's captured on the CRD of, hey, I want a RDS database, then the RDS controller is going to reconcile that desired state with actual state and create that, provision that infrastructure inside of Amazon. That works for a lot of different cloud providers too: Amazon, GCP, Azure, Alibaba, and others as well. Okay, so then building though on that basic ability to create infrastructure from inside of Kubernetes is the second main feature area. And this is where, this is kind of new, and this is where I think a lot of the power of the Crossplane platform starts to show itself. So I think this is really important. But yeah, so, above and beyond being able to just plain create infrastructure on demand, you could start defining a platform in your own API, your own infrastructure API around that infrastructure that you want to create. So for instance, a common scenario here is an application team needs infrastructure, and you want to be able, as an infrastructure owner, to be able to provide that for them on demand, but you don't want to give them the keys to the kingdom either. You don't want to say, hey, here's an Amazon login or GCP creds, go ahead and create what you need. Nobody really wants to do that, right? So what this is doing is that it'll enable applications to get the infrastructure that they need when they need it on demand, but hide it all behind an abstraction, an API, a platform. Kind of build your own platform here, where you can be very opinionated about what it means for to be an infrastructure in your organization. So a great example here that kind of makes this a little bit more tangible is that think about what it means to run a MySQL database inside of Azure, let's say. So not only do you need the MySQL database managed service, but you also need a resource group for it to run in. You need a firewall rule for ingress, or for people to actually be able to connect to the database. So that's all well and good. But if you want to give the keys to the kingdom to the application and have them create all that themselves, that's it's kind of a burden for them. It's giving them too much control. But instead, hiding that all behind an API, a simple API that says, hey, as a platform builder or operator, I'm going to define what MySQL means to me and my organization, and I'm going to put that all behind this API. And the application developer, all they need to know is that they want Postgres. They can simply say, hey, give me Postgres and this API that I've published and I've made available to them. And then all the configuration, the policy, the definition, all that stuff that I care about as an infrastructure operator is available for them to access to the API without having to know any of the details. So it hides all that complexity. It puts some policy guardrails in there. And the nice thing about this is, and we'll see this in the demo, is that it doesn't require you to write code. So you can build your own platform, you build your own API without having to write any code. It's all declarative. This diagram here makes that a little bit more clear what I'm talking about. So let's go left to right here in the diagram. So first you define infrastructure in your organization. Say, hey, I want to define some MySQL here. What does MySQL mean? And then you could start really, expressing what MySQL means in your organization. So for instance, it could be Azure, MySQL managed service with the resource group and the firewall rule, or it could be something in Amazon instead with the VPC, subnets, security groups, all that sort of stuff. You're defining what MySQL means with all the environment complexity and the policy and configuration and all that sort of stuff. Then this is all behind the API that you're publishing to your applications, to your consumers. When an application developer says, yes, I have a requirement for MySQL, I want to use Azure, that's all they have to care about. Then they're calling basically into the API there. It's all based on the Kubernetes API still, by the way. So they're getting access to your platform API and getting the MySQL they need without any of the complexity and without getting the keys to the kingdom either, or being able to do this directly in the AWS console or AWS CLI, etc. So this is kind of a picture of of what building your own infrastructure API looks like, and then consuming it as well. And then the final section here is about running the applications themselves. So as we mentioned before, we worked with Microsoft and Alibaba on the open application model, the OM spec. And so, that really kind of has very similar philosophy that Crossplane does around this, a separation of concerns, but there's different personas involved here. Yeah, the application developer is not the same person who's running the infrastructure, who may also not be the same person that's operating the application. So, being able to specify different levels of access or different areas of concern, kind of through these abstractions here, it gives you the ability to be very clear about what you want in your application, and not have to be very, very specific about defining where and how it runs if that's not really your concern, if you're not the infrastructure operator, let's say. So yeah, Crossplane is the Kubernetes implementation of Ohm. So we'll see that as well too, more further on. And then to put it together in a final little picture here before we move on to a demo and see it in action, is that we've been talking about being able to provision infrastructure from Kubernetes directly. We've been talking about building a infrastructure API that exposes infrastructure to your applications and when they need it and how they need it. And so this kind of defines that here, where there's this API line in the middle of the diagram here. And so the platform builder, infrastructure operator, they defined what it means to be MySQL or any number of other services. And behind that API line, they'll be talking to the cloud providers, to their APIs to set up this infrastructure when it's needed. And the people that actually need the infrastructure to consume it, the applications, they can come in through your platform API that you've defined in any number of ways. They can speak directly to Kubernetes, using kubectl or anything that talks to Kubernetes API. But you can also do, CI/CD pipelines or infrastructure as code tools, Terraform, et cetera. Because you've defined an API, there's many number of ways that it can be accessed when it's time to consume or ask for, request the infrastructure that is needed for an application. Okay, so I've got a demo here to kind of show this in action and dive into how some of this works and what the experience is. So, okay, let me get everything up here. All right, so I think you should be able to see a terminal here. And I am just running a Kubernetes cluster locally on my laptop here. It's just a Kind cluster. And so it's not too special, and there's really not much going on here either. So I'm going to go ahead and take this vanilla Kind cluster, and I'm going to actually get Crossplane running for us as well. So to get Crossplane itself, it's basic CRDs, its controllers, etc. I'm just going to use Helm to download and install that and get this onto my Kubernetes cluster. So now I'll have all the machinery that I need to get the basic controllers and CRDs running for Crossplane. So let's take a look at the pods that are running here. So we see here now that we've got a Crossplane pod and then a little package manager for Crossplane as well. That package manager is important because when we want to, Crossplane by itself, it doesn't know anything about Azure, it doesn't know anything about GCP. So you can use Crossplane's little built-in package manager to add extra support. So for instance, I just installed the support for Azure using the kubectl plugin for Crossplane to say, hey, install a package for me that is called the Azure provider. So now my Crossplane cluster knows how to speak Azure. You can you can go ahead and create instances of Microsoft Azure infrastructure now. I'm going to do the same thing for GCP as well, where I'm going to say, hey, please go ahead and install the GCP provider package as well. So that's in the cluster, and that is ready to create and provision infrastructure inside of Google's cloud as well. So let's make sure that all those are done and ready for us. So we should see here a set of additional pods running now. Yes, the Azure provider is running. It looks like the GCP one is still coming up. Okay, now that's ready too. So we've got vanilla Crossplane. We've got support for Azure. We've got support for Google. Let's go ahead and do something with it. Until we Crossplane, it could speak to Google, but it doesn't have any credentials right now, right? So I'm going to go ahead and copy over. Oops. I'm going to go ahead and copy over. It looks like I already have my credentials file, but I'm going to go ahead and create a secret here that basically captures my GCP credentials. So they're stored in a secret inside the cluster so that the GCP controllers can use that to then make API calls to GCP. So using that secret, I'm going to go ahead and create, basically give access to that secret to the GCP controllers inside of Crossplane. All right, so everything's set up now, and now we get to do something real here. So let's go ahead and start defining some infrastructure. Let's define a infrastructure API and infrastructure platform right now. So what did I just do here first? So I basically defined some infrastructure, and now this is where things start getting interesting here. So basically what I'm doing here is that I'm trying to get the applications that I'm servicing as the infrastructure owner. I'm trying to get them able to bring up Postgres on their own. And so I'm going to say, hey, here's something, a new set of infrastructure in my environment called Postgres. And so, what do I want to expose on this Postgres to applications that need it, right? I'm going to go ahead and expose some configuration knobs to them in the form of a schema for it. So I'm basically only exposing one configuration knob here. I'm saying, hey, how many gigabytes do you want this database to be? And this is the only configuration that I'm going to allow applications to specify when they're creating a Postgres instance. So I've created that, but now, which in turn creates that infrastructure definition. This is now defined in my environment here. Now I've got to publish it too, because I've just defined it, but it's not available for any applications to use. So I'm basically going to publish it to say, hey, that Postgres that I created for my organization, go ahead and publish that in the default namespace so that applications can actually use it now. So this one's pretty simple. So we should see here that there's a new CRD that represents Postgres for applications to use it and request it when they need to. All right, so we've said there's a new infrastructure API that I want to publish for applications to consume it, and it's Postgres. But what is it though, right? What is Postgres? And so there's three separate definitions of that I'm going to provide here in my platform. So I'm going to say, hey, you can create Postgres, but which one do you want? So I'm going to create a bronze, a silver, and a platinum Postgres. And so the details of this is really important. The details of each one of these implementations of the Postgres abstraction all are behind the API line. This is all things that as the infrastructure operator or owner, I am defining, but this is policy and configuration that will not be exposed or configurable to the application who's requesting the infrastructure. So in my bronze one, I'm just going to be, it's a general purpose. There's only 2 cores. It's pretty weak as a database. It's lower tier. It's cheap. It's not that good. But then also, I'm going to have a platinum one, which is more memory per core. It's 32 cores, etc. This is all behind the API line, so the applications can't configure this or can't have any influence on this. Now, an important part here, remember, is that Postgres means many different things in many different environments. And so here in the platinum and bronze definitions, that's actually in Azure. So it means it's a resource group in Azure, the Postgres managed service, a firewall rule as well. That's what Postgres means for the bronze and platinum implementations that are in Azure. And then something entirely different is for silver. That's not even in Azure. That's actually in Google. So we're showing that this platform, this Postgres abstraction, this Postgres API, can have different implementations underneath. And so in Google, it's going to use Cloud SQL. But overall, the application doesn't have to care about that. All they care about is that they want Postgres, and they want to be able to turn the knob on how big it is, and that's all that they have to care about. So that's what those compositions are. And let's go ahead and create these compositions so that they're defined. And so we should see here that we have 3 different compositions for Postgres, this Postgres API I'm defining: bronze, platinum, and a silver. And so I'm going to go ahead and kick something off real quick to get this going, because this is actually going to bring up something in GCP, which takes a while. So I kicked that off, but let's explain what I just did. Okay, so we defined Postgres in my environment. We published it. so that applications could request it when they need it. And then we defined a number of different, compositions of what Postgres actually means. We defined a couple in Azure, we defined one in GCP, we defined various levels of performance for them. So that's all, behind the API line. Now let's look at what the application has to care about, right? So an application that needs a database, it needs Postgres. It's going to go ahead and express in very clear and simple terms that it has a requirement for Postgres, right? So this is what the application developer cares about. They would go ahead and create an instance of this CRD here. The post is expressing, hey, I require Postgres for my application. And remember that we only exposed, when I created this API, I only exposed one configuration knob for them to turn, which was how much storage does the Postgres database have. This is not exposing, the type of instance that's being used, the firewall, like what it means, the resource group, firewall rule, et cetera. The application has no idea about any of that stuff. They're just simply saying, I require Postgres and I want it to be this big, and I want the silver one. So they don't even know if that's a GCP. They don't know if that's Azure. It doesn't matter. They're just saying, I'll take the silver flavor of Postgres, please. And then underneath the covers, the Crossplane machinery and this custom infrastructure API that you've defined will kick in and say, okay, so somebody's requested Postgres. They want silver. Which one's silver? Oh, okay, so silver is the one that silver here. Silver is the one that's in GCP, and it has these particular parameters. And then the storage that they requested, that the application requested, we'll go ahead and flow that in too, so that this Cloud SQL instance that I'm creating with a bunch of policy that I specified and specific configuration, I'll also take into account what the application has requested as well. So they said 20 gigs, I'll give them 20 gigs, no problem. And so then that will make calls from your control plane here, from your Kubernetes control plane infrastructure API you defined, that'll start making calls out to Google, out to GCP. So if we go over to GCP, we should see a new database that is starting to come up inside of GCP. GCP console's a little slow, refreshing itself, period. Yep, there we go. But we see this database that the application requested, we see it coming up now. It's in the pending create, it's going to be provisioned, initialized. And so let's take a look at some more things under the covers here. So my application asked for Postgres, and that's going to mean something underneath the covers, right? That we talked about. The application said, "Give me silver Postgres," and then underneath that's translated to a Cloud SQL instance. So all these things are represented as objects in Kubernetes. They're CRDs and objects inside of the Kubernetes API. So we can see specifically the Cloud SQL instance that the application is getting through this platform API defined. It's in the state of pending create now, so it's still coming up, and Google Cloud is working on that to bring it up. And so one of the nice things about the Kubernetes API design, right, is that it's all active reconciliation. So the users requested this Postgres, and our controllers are reconciling it, trying to make sure that the desired state of that Postgres is aligned with the actual state inside of Google Cloud. So the controllers are sitting there in a reconciliation loop. They're checking on the Google Cloud status. They're seeing, they're checking progress there. They're seeing if, when it's done. And then once the Cloud SQL instance is done, then the controllers of Crossplane will be able to take the next steps to be able to get that infrastructure, now that it's provisioned, get it ready to be consumed and used by the application that requested it. Let's take another look on this, and it's still creating. Well, it looks like it might be just about done here in the Google Cloud Platform. So let's take another look in with the Crossplane controllers here. Let's look at some more details on it while we're at it, because this is all represented as CRDs in Kubernetes. So we can do like a kubectl get on that Cloud SQL instance, and we could do things like look at the full instance of it, like all the YAML of it. So, oh, and now I put out the whole YAML and it now is ready. But basically it's just a CRD with a spec and some status reporting on the real life, the real world actual state of this instance, right? This Postgres instance. So if we look at it again, yes, we should see that it's runnable. It is ready to go. Great. So the application asked for Postgres through an abstracted API. It's got the particular silver Postgres that it requested that happens to be in Google. And now let's use the darn thing, right? So one final guy here is, oh, sorry. In order to use it, we need to get the information for it, right? So the Crossplane machinery there, when you requested Postgres, and it talked to Google and brought one up for you, it also published the details about the endpoint, the username, password, etc. It created a secret inside the application's namespace so that the application would have the details on where to find this Postgres instance and how to connect to it. So we've got a secret published for it. And so now let's go ahead and create a pod that is going to finally use this infrastructure that we on demand provisioned through our platform API that we defined. So I created a pod, and let's look and see what this pod actually does. It's super simple. It's just going to be a pod that starts up in the control plane here. It's going to run pSQL and just connect to the database and do a select on the current database just to know that we connected to it okay. But how did it know where to connect? So remember that secret, the connection secret with all the details, we're importing those into here in our pod as environment variables. So we're setting like the Postgres host, the user, password, etc., as just fields off of that connection secret that the Crossplane machinery published for us. So this pod should be able to talk to and consume the infrastructure that we provisioned for it. So let's take a look at the logs real quick, which should just show us, the pSQL query output. Yay, which it did. So let's put it all together here one more time. That as an infrastructure owner, I defined a platform, an infrastructure API, to say, hey, I want to be able to provide Postgres to my consumers, my application teams. This is the knob that I want, configuration knob that I want them to be able to turn. I want them to be able to say how much storage this database should have. I'm going to publish it for them so that in the application namespace, it's ready for them to consume and to say that they need Postgres. I'm going to give a couple different options for the flavors, the implementation of Postgres. When the application says they want Postgres, I'll give them bronze, silver, and platinum, which mean very different things underneath the covers. But to this abstraction of Postgres, the application doesn't have to care about that sort of stuff. And I don't have to give them the keys to the kingdom either. They'll get the configuration of policy that I care about. And then finally, the application says, okay, I require Postgres, and they get that for them, provisioned on demand without being able to specify which flavor and how big it is. And then a pod, the actual application itself, right, a containerized workload, can then consume the infrastructure that was brought up through the connection secret and the connection details that were published by the platform. All right. So last couple slides here. There's a couple links here to news articles about our collaboration of Crossplane with Microsoft and Alibaba on the OM spec. Little news article about becoming a CNCF project recently, and also about a partnership with GitLab or being able to deploy GitLab itself using Crossplane across multiple clouds. Just a couple stats about the project. It's about a year and a half old. It's starting to gain a little bit more traction now since we became a CNCF project. The container downloads has gone up significantly. My favorite is always how many contributors there are though. We're like 50 or almost 50 or so people working on it, and that's continuing to grow every day. So we're building this community around Crossplane, and really happy to have people join and not only use it but also contribute to it as well. Just a couple of adopters that we've listed here. Microsoft and Alibaba are obviously very involved in the Crossplane project. GitLab, Red Hat as well, and then another number of other companies and partners are starting to adopt Crossplane and start using it in their environments. A lot of them are at the evaluation level right now, just kind of kicking the tires and getting more involved with it and providing a lot of feedback, but as we continue to advance to, from early alpha days to beta towards V1.0, then we'll continue to grow this list, which is exciting. So, a quick roadmap update, what's left on the project, or where are we heading with all of this that I've shown you today? The next big step is getting that V1 out, right, ready to be production, out in production deployments. And so a number of things that we're going to be doing on that, this composition and, platform API, defining stuff that I've showed you here. It's alpha right now, but it's going to be moving towards beta and on the way to V1. They have the package manager that I was talking about there, being able for that to handle upgrades in place and make some more reliability and robustness around that. The providers that what talks to the cloud providers, GCP, Alibaba, Microsoft, etc. We want to expand the scope of those significantly. So we're doing a number of things like code generation and bootstrapping with some of the Terraform provider implementations to expand the scope of services offered from, I don't know, like maybe around 100 or so, 75 or 100 right now, to 90% of the cloud providers' full service offerings. So that'll be a really good win on expanding the scope of what Crossplane can help you manage from inside of Kubernetes. And then finally, a new architecture update here is that being able to consume infrastructure from many of your clusters is super useful, where you can define your platform API centrally, where in some Kubernetes cluster where you have Crossplane running, and then any number of application clusters that you have running will have this agent that runs inside of each one of those application clusters, and it will be able to basically sync the platform infrastructure API that you've defined in your central control plane, and have that be surfaced and available for consuming infrastructure by your applications in all of those application clusters. Cool. And last slide here, I think, is more links to get involved. Crossplane.io is the main website. GitHub, we're super active on Slack, and a couple other links for a blog, and Twitter, YouTube, etc. But yeah, we'll be in the Project Pavilion this entire week at Kubecon, and we'll be there on the chat and everything. But long term, Slack is pretty much where to find us. So slack.crossplane.io is where we can keep talking and collaborating and listening to feedback, and onboarding new contributors and keep growing this community here. Cool. So that is about it then for this project office hours walkthrough and demo and everything like that. So if anybody had any questions, we're happy to take those now, or we can keep the conversation going in the booth or on Slack or whatever works best for everybody.
Yeah, and if people are comfortable introducing themselves and just having like open conversation, maybe tell us what got you interested in Crossplane, and kind of what you got rolling in your environment. That'd be super awesome too. So it looks like we got Mike and David and Gert on the phone. Are you guys able to hear us?
Yep, it was a good presentation.
Oh, hey, Mike. Nice to meet you.
Hey guys.
Where are you based out of?
I'm based out of Austin, Texas.
Oh, right on. Yeah, I did a startup out of Austin a little while ago. I really liked it there. So.
Yep, cool.
Hey,
yeah,
Mike, you're involved with another CNCF project, aren't you? Right? Or is it?
Oh yeah. I work on most of the OCI projects. I'm a Containerd maintainer.
Yeah, Containerd, that's the one, because I remember we had run across paths sometime in the past briefly. And I was thinking it was either that or it was Linkerd. I couldn't remember which one it was.
Yeah. Nope, not Linkerd. Containerd.
Awesome. Good to see you again, Mike.
Yep, cool. Yeah, I do all the CRI, or a lot of it, right? CRI work, hooking up between Kubernetes and Containerd.
Is that for your day job, Mike, or is that like a volunteer sort of thing on the side too?
Yeah, my day job is OSS programmer for IBM.
Oh, okay, at IBM, got it.
Yeah, so I get to work on pretty much any new container project I want to work on. It's pretty cool. Having a lot of fun. Yeah, I've got the call in about 5 minutes, so I'm the next maintainer.
Are you doing another like a office hours for
Yeah,
Containerd? Oh, cool. That's exciting.
yeah. Mine is in about 5 minutes. I'm not sure how I'm going to run mine. I might just let people, answer questions, that sort of thing. I do have some decks, but yeah.
Yeah, that's one thing that's cool about Containerd is it's pretty well established. It's been out there for a while, and for this session here, we're kind of still putting the name out for Crossplane and explaining what it does too.
Right. Yep.
Containerd, that's graduated, right?
Oh yeah.
Nice.
Yeah,
How long ago did that happen?
Right about a year ago.
All right. Nice.
Yep.
Well, good luck on.
We need to do more of it. There's always more things you can do, right?
Yeah, absolutely, for sure.
Yep.
Yeah, good luck with your office hours today as well.
Yep. Yeah, you guys have any questions about all that stuff? Or
yeah. It looks like Phil, we got some questions on the chat as well.
Oh yeah.
Do you wanna take that, Phil?
Yeah. Parts of infrastructure, CIDs, and custom operators. Yeah. So so Crossplane basically allows you to have this great framework for defining your infrastructure as CRDs that solves a lot of the really gnarly problems. There's a Crossplane runtime that has a really great managed reconciler in there that just makes it a lot faster and more robust to kind of implement your own infrastructure as CRDs. And then the other cool thing about Crossplane is that you can then compose those without writing any code, just with YAML, and then those basically get published as their own CRDs. And so you can effectively, write your own primitives as infrastructure primitives, and then composing them basically is something that Crossplane supports. And then you can provision those composed resources directly from Kubernetes or from Terraform with the Kubernetes provider that Terraform just came out with a little while ago, or any of your existing tooling, keep control from your CD pipelines or whatnot. So definitely would encourage you to take a look at that, and happy to walk through and drop a link to our blog post here that has a link to the services developer guide that'll kind of walk you through that in more detail. And it'll also have some of, let's see if I can just do this to everybody. There we go. Links to some of the additional talks that we have. And then as far as OpenStack provider, we've had a couple issues opened recently to add support for that. And I think there are a couple people that might be in the community that are exploring that. So I would encourage you to join the Crossplane Slack. We could probably get like an OpenStack provider channel. There is a provider channel in Crossplane Slack, so you could probably just drop in and say hi there. And then get connected with the folks that are doing that if you didn't want to search around on GitHub. But I'm happy to put you in touch, and feel free to reach out to me on Twitter or directly. So yeah. I'm at Presic on Twitter. Creating an infrastructure on VMware. Oh, hey. Yeah, so we actually have multiple initiatives going on there right now with one very large company, financial company that is kind of building out a set of VMware providers, and then we're also exploring the possibility with VMware directly of getting that going. So super exciting time, and Crossplane is designed not just to manage in the cloud infrastructure, but basically anything that has an API that you can provision on-prem. So VMware definitely is in that group of things. We're also doing an integration with Packet. And so that's basically a Packet provider that's out of the, I guess Packet just got acquired by Equinix, right? So they're now Equinix Edge Metal, but we have some work coming out with them as well. So provisioning machines is definitely in the purview of what Crossplane can do. Great question.
Edge Metal is a super cool name, by the way.
Yeah, right?
That's awesome.
It's like, of course I want that. Maybe they'll have like a samurai sword or something like that, And then is it Adit or Aditya? If you have any more information about your use case, would love to chat more on the Crossplane Slack. If you just want to drop in on the general channel or drop on the provider channel, that'd be a great place to go. Cool. Yeah. Awesome. Yep. Happy to chat more. And we'll have our booth as well, but yeah, connecting on Slack is probably a good way to go for faster response.
Awesome. All right, let's I guess go ahead and wrap this up then. And thanks everybody for coming in, and enjoy the rest of your Kubecon, and we'll find you on in the booth and on Slack as well.
Yeah. Happy Monday.
See y'all, folks.